Trying to figure out what's going on with the seating in this class. It's really strange, and it's been consistently this way every time I've had this classroom. Is that the back row is just always jam packed. Everybody's trying to get as far from the action as possible, and then the second row is kind of everybody there, and third row, I don't know what it's going on. Like there's always people over there. For some reason, there's always people that congregate here, but like the middle is just like left alone. I'm not sure like what the philosophy is about the middle not having any seats in there, but is there any rationalization that we can actually provide for this? Any pattern recognition? We're talking about pattern recognition in this course, and so we've got to try to figure that out. So what's up, Clayton?
Actually, for the holidays.
Oh, okay. Yeah. That's a fair. There's actually in my auditing class, I was given a hard time because there's four guys who always enter the class at the same time, and they sit in the same area, but they shuffle around chairs depending on who it is that needs their laptop charged. And so I'm really bad with facial recognition when I've not had students for multiple classes, and so I'm still struggling trying to remember each of their names. And when they mess around with the chairs, it just really throws me off. So yeah. Uh, so um, so real quick, this is not relevant to the course, but in case you didn't know, it's Dr. Caden's birthday today. So you can go and wish her happy birthday. Uh, I'm not going to tell you how old she is, but I will say that 4 years ago I got her a happy 400th birthday cake, and so she was a little bit salty about that. But yeah, it is her birthday, so yeah, no more deserving person for recognition. And I guess if you're around at 3:30, there's going to be like a big ceremony, and this is nobody will probably be around. You may even get a slice of cake. So that's just, a little bit of addition. I'm going to talk probably more about this on Thursday, but I did want to bring this up. So as you are aware, there is a graduate student assignment. So for those of you who are not in the graduate section, that's fine. I wanted to make this announcement. So the graduate student assignment is going to be a healthcare investigation presentation. I'm working on the instructions for that right now. I actually met kind of I guess the adjudicators would call him. His name is Ken Zico. He's a former healthcare lawyer. He's actually a former mentor of mine from KPMG. And maybe I'll tell the story of how he saved my career at one point. It's actually an interesting story. It's because you all know I have a very quick wit and a very fast mouth. It was much worse 20 years ago. So I said some things to a partner that I probably shouldn't have because I thought I was being clever. And turns out partners don't want to be called out when they say something that's completely and totally incorrect. And so Ken saved my career, and yeah, I managed to make it a little bit further than I would have otherwise. But he's a very, very knowledgeable fellow, very, very bright, and he's going to be kind of viewing the presentations. I will have some detail on that. I do want to make a note that I'm going to change the date of the presentations to April 21st instead of the 23rd. I have not made that change on Brightspace or in the syllabus yet, but I will eventually. If you are not planning on doing 3MT competition, please know this will be a rigorous exercise activity. So this means that you're going to be presenting at a professional level. You will not be able to phone this in because he will call you in on shenanigans. And if you use AI tools, he will ask you to articulate the details of what you presented in much detail. So we're not sure, not 100% certain. Probably what we're going to be focusing on is investigations related to healthcare, famous healthcare cases, or even not famous ones. Some of the ones that you may encounter may have actually had him involved with them because he actually got involved with several of those. But I don't know his name will be in the details. And then there's probably going to be some areas where we can talk about healthcare concerns, but I'll articulate that to you once I have the instructions worked out. Hopefully I'll get that done tomorrow or today. It may be later this week, so we may be talking about it next week, but I just wanted to make everybody aware. Anyway, today, we're going to be talking about the third part of the investigation. And this is my favorite part of the investigation part. So I know the interviewing is kind of what you think about in your forensics as like an interrogation, sitting somebody in a dimly lit room and asking them difficult questions. It's not really how interrogation goes in the real world, but actually kind of what you all were doing on Tuesday is much more a representative interrogation. The only thing that really didn't meet what I would say is a traditional interrogation is usually there's only one or even two parties present if we talk about attorneys being present for that questioning. There's usually only one party being interrogated, and then so a group of individuals was only there to kind of facilitate the Q&A. But yeah, usually multiple groups or multiple entities that are performing the interrogation. So I think it was an effective means and something we will replicate here over the course of the semester. But the reason I decided I want to talk about this, first of all, this is a burgeoning area of forensic investigation. And so we talk about forensic data analysis. I would say that this is going to be far more prominent than traditional investigation and inquiry, simply because this is where a lot of the document analysis can take place. And so I think it's important to get into a little bit of detail. I'm not going to focus so much on the high level aspects of data analytics because my assumption is to some degree or another, everybody in this room has had some sort of exposure to that in one or more of their courses. What I'd like to talk about is how this is relevant to forensics. And again, those of you who have had classes with me before know my story about this. This is actually what I did when I was at KPMG. I did forensic data analysis. And so I've got some fun stories. One of those actually involves the guy I was just talking about, Ken Zico. I think I've told the story, and if I have, I apologize because I'm very, very consistent about repeating my stories over and over again. But at least a few people I know haven't heard this story. It was actually we were working an idea, and he was doing an investigation on an annual. I don't think it was an investigation; it was annual inquiry into one of his clients, and they extracted a very large database that he had one of his individuals that he was working for him put it into Access so they could do the data analysis for it. And it took her about 40 hours to do it. She was very, very good at Access, but it was just not a very time-saving routine. And so he sent it to me and says, "Could you do this? Could you do this for me? How long would it take you?" I said, "Oh, probably about 4 hours." And he was just like, "What? This takes us 40 hours right now." I says, "Yeah, well, I mean, Access is a much more difficult tool to use to idea for importing and querying. So this was kind of something that, and he thought I was bragging, and I actually did it in 4 hours. It was pretty impressive. The problem is that the budget for the engagement went way down, and so they expected to replicate that. And I wasn't at KPMG much longer after that, so they had to find somebody else who could do that in 4 hours, which I don't want to toot my own horn, but there's nobody else who can work an idea in 4 hours than I can. All right. Anyway, so I had you look at some resources and answer some basic questions, and let's go ahead and get over those questions. Some of these are going to be very minimal in approach, but fairly intuitive. And I did not write down group members' names, so let's see. Hold on. How am I going to do this? Hold on. Give me just a second. Okay, I've got a solution for this problem. Not a good solution. I'm going to pause because I don't want this to be taking up the airtime. All right, so some of you may have been asking, why did I just scroll down and take a picture of the group names on the screen while I was paused? I only thought of that when I was about halfway into my process, so that would have been a simpler solution, but we're here now. Okay, we're here. So, according to the first resource, what is forensic data analytics? Alex, what did your group say on this one?
We said that it is a branch of digital forensics that focuses on analyzing large volumes of data to uncover patterns of criminal activity, such as fraud, cybercrime, and money laundering.
Good summary of that. So basically, it's data analytics, but with a forensics twist. So data analytics for forensics. Forensic data analytics is data analytics for forensics. That's how the definition works, guys. Okay, I don't make up the rules. But so the important part of this question is, according to the first resource, what are the stages in a forensic data analytics process? Jenna, what'd your group come up with on this one? Okay, so data acquisition, examination data, analysis, and reporting. Now, I don't know that this is unique to forensics, but I think that this is an important template for us to operate from, and we're going to use this to kind of explain and expand upon this. But I think you could use this template for any type of data analytics, but this is the ones that are defined according to forensic data analytics. Now, this is an interesting one and something that we've talked about in other courses, and I'm sure that you've talked about it in many courses beyond the ones that you've had with me. But the first resource notes that many organizations are experiencing limitations of legacy systems. Okay. What is my favorite one to poke fun at, by the way? Does anybody remember the legacy system that I like to poke fun at the most? It's the IRS. I like to poke fun at them. They're operating on a 60-year-old infrastructure. Okay. Yeah. Are they ever going to update? Never, never. What was good enough back then, it's good enough now. Doggone it. Yeah. So, based on what you've learned in previous courses, what type of limitations does the statement refer to? So, this is kind of a challenging question, but I have no doubt Cole is up to it. So, what was the answer to that?
So we said it just means that old technology cannot effectively be used to investigate fraud that is conducted with newer technology. It's a lot less efficient and effective when it's outdated compared to the newer technology that's being used for us.
Very good, very good. So, and querying the databases are really problematic simply because they're legacy systems. So, harkening back to AIS, for those of you who had me with for AIS, What's the name of the kind of systems that we operate with nowadays? The kind of the systems that we've been operating with for like 30 years. I know 30 years seems like a long time, but it's actually relatively new in the grand scheme of the universe. So what is the name of the systems? What is that category called? Well, you're on the, I guess I'm not being specific enough. You're both right, but okay. Are we using conventional or database systems? Database systems. That database system has been in place for like 30 years. Okay. Now, how is that different from conventional systems? The conventional systems are basically like take a piece of paper, put it on a computer. All right. You can't pull individual pieces of information out. Now, why is that important for forensic data analysis? If you can't query a system, you can't analyze the information within the system. You can't analyze the data within the system. As Cole said, it's going to make it very, very challenging to perform detailed data analytics on that. All right. So speculate on how forensic data analytics could address such limitations. The answer is if we can convert these systems into more traditional, to more modern, I shouldn't say traditional, to more modern systems, to more modern formats, that it makes the data analytics much easier. Now, we did get a taste of that for those of you who took auditing with me and actually got the joy of doing IDEA. That's not everybody in the room because of the technology issues that we had last year. But for those of you who had that joy, and it was a joy, trust me, remember that you had to do some importing and some analysis in some non-conventional formats. Does everybody remember importing PDF files? That sucked, but it was really, really important to take a lesson into that. It was time consuming. It was really, really difficult. You had to go through setting up those traps and specifying what a trap looked like, how it could import some lines of data. Yeah, it was tedious and boring, but how many other tools are very effective in importing PDF files and data in that format? To my knowledge, there's not that many, to my knowledge, and I've got a lot of knowledge, believe it or not. I've lived a long time and made a lot of mistakes. So, yeah, it's important to note that having any tools that are available to do non-traditional tasks is really, really critical to have. All right, so the second resource identifies 5 steps in digital forensics. What are they? All right, so I think Joe, you're up on this one.
Identification, preservation, analysis, documentation, and presentation.
So identification, preservation, analysis, documentation, and presentation. All right, I'm going to stick with Joe because that was such a well-done articulation of this, okay? So how well do these steps align with the stages that we identified from question 1?
We said they aligned well because data acquisition aligned with like the identification and preservation step, then examination aligned with documentation, analysis aligns with analysis, which is a direct alignment there. Then reporting aligns with documentation and presentation.
Yes, and I would agree with that. There's a fairly straightforward alignment. The only one that I think probably should have been explicitly stated in the first resource that was not, and is stated in the second resource, is preservation. And that's a critical item because we need to know what is the source of the detail that we provided. What is the source of the analysis we have? So remember when we talked about Excel files and we say, what's the problem with doing analysis in Excel files is that you change the underlying data. So what was a good practice for data analysis when you did Excel? You saved an original copy of the file. You made a copy of it for your analysis. That way you don't actually corrupt the underlying data. That's a step in preservation. That's the kind of idea that we're talking about. More modern technology tools. Don't get me wrong, I love Excel. Excel's like a father to me, okay? But I love Excel, but it is kind of outdated and outmoded compared to some other modern technology tools that we're going to get into a little bit more detail. So yeah, some interesting questions. Again, I don't think these were particularly difficult questions, but they do make you think about how this relates to other data analytics activities that you performed previously. So you had to know that was coming because it's me teaching the course, but we're going to talk about AI. We're going to talk about AI. By the way, this is not relevant to this particular discussion, but has anybody seen like the Trivago commercials either on TV or online? Like Trivago is like this hotel booking company, and they're based in Europe. The only reason I mention this is that they, for their first few commercials recently, they were doing a well-known soccer star. He was actually a soccer coach. His name is Jurgen Klopp. And if you've ever seen this individual, he has got the most brilliant white teeth that you can ever possibly imagine. Like whenever he smiles, it's like the entire room just lights up. Okay. And so there was a lot of memes going around on the internet about him. And the reason I bring this up is because Trivago was thinking that this was bad publicity, and they re-edited one of his commercials to feature an AI actor. Now, if you ever find this commercial, you will notice immediately it's an AI actor. It stands out like a sore thumb. Actually, that's not even a fair analogy. A sore thumb would stand out less. All right. It's just like The rest of the background looks like reality. It's like a cartoon character jumping around in reality. It's like Roger Rabbit. All right. That's basically how bad it is. So I don't know. This is again not relevant to this discussion, but I wanted to say that AI is not a perfect solution for everything, which again, knowing me, you're probably saying, how dare you, Dr. Barnes? So the first resource talks about AI tools that can improve forensic data analysis process. So what might be some ways that AI tool might represent an improvement over traditional forensics analysis? So if we're talking about improvement over traditional forensics analysis, oh goodness gracious. Okay, sorry, I lost my place. Let me get down here. Jack B, I think it is the group leader. So what does your group say on this one?
The article mentioned that it can provide predictive modeling to prevent future fraud from occurring, and then it can also help companies see the big picture by analyzing numerous data sets that span across all areas of business. Unlike traditional methods, we may just look at a certain area.
Yeah, so predictive modeling, definitely data volume. What can we say about processing speed with respect to AI tools? Are they faster or slower than human beings? Much faster, way faster. Okay. So there's definitely some advantages, and I think that those are only going to improve over time. But the whole point of this, me bringing up the whole Trivago ad, was to say AI tools are not perfect. So what might be some issues with using or reusing AI tools? So I say, why might AI tools be less effective than traditional methods? Okay. So Alex, I gave you a pretty easy question last time. I'm going to give you a much harder question this time. So what was your answer, your group's answer?
We said that AI also relies a lot on the quality of data that's being put into it. So if the data is not fast, the output is gonna be very effective and not help solve.
Right. So AI will take whatever is given to it and will try to analyze it. And it can't notice if there's problems with the data. Now, some of these could be very, very straightforward for the AI tool to deal with. Like there's gaps in the data. We do know that there's tools that can actually address that. But what if there's data that just doesn't make sense in a certain context? Will the AI tool be able to identify that? Currently, probably not. And so that's one big problem. Another one that I kind of identified that I thought was interesting is the fact that when we talk about AI tools are really good at identifying existing problems if you can specify the existing problems within a specific framework. But what about if an AI tool should encounter data analysis for new problems that have not been previously detected? Does it have the critical thinking skills to identify new issues within the data? Probably not. Okay. Again, maybe in the future, but we're not there just yet. We're not there just yet. All right. Moving on to question number 5. So 6 steps in conducting a financial fraud investigation. Everybody remember that? So say them off with me. I'm just joking. All right. So 6 steps in the financial fraud investigation: consultation, examination, identification, background, asset discovery, and legal action. All right. So there's a lot going on here that we talked about last week, and then we talked about the steps from the question, the ones we identified in question 3, which are those 5 steps in digital forensics. So assume that you're conducting a financial forensic involved in, let's go to how these steps differ from those you identified in question 3. That's the first question. So Jenna, what'd your group say on this one?
So it doesn't the analytics process, but it still lines up fairly well. The identification step is identical, and then legal action is most likely comparable to presentation, and consultation is a step that's missing from the 5 steps.
Yes. So I think we can identify several steps that are kind of different between those. So consultation, background, asset discovery, we're in the investigation process, whereas preservation analysis and documentation, those are kind of unique. Now that's splitting hairs. I don't think that there's a lack of documentation in forensic investigation. I just don't think it's explicitly stated. That being said, can we argue that both of these are procedural steps? So these are all procedural steps. I think they're all procedural steps, but they're necessarily aimed at different goals because investigation is going to have a different direction than forensic data analysis. They're related, but it's different. Now, I'm going to kind of answer this next question because I think my response to this one was a little bit cheap answer. So the next question was, so what set of steps would you use in your investigation if you had to use an investigation with forensic data analysis? And hopefully you came up with the same answer, because otherwise I'm going to feel really, really foolish, because my answer was both. And you may have had a different answer. Your answer may be, it depends, which is also a good answer. Okay. But it's still difficult to conduct an investigation with forensic data analysis and not have both sets of steps. So if I said you had to choose one or the other, then it may have been a challenge. You may say, I don't know if I could choose. You may be still sitting in the room where you were working, trying to figure that one out. But if you could say we could use both series of steps and come up with a reasonable approach to this particular problem, then that would be an additional a way that we would want to approach that. All right, question number 6. First resource states that forensic data analysis frequently combines structured and unstructured data. What is the difference between structured and unstructured data? This is a throwback. I gave you a difficult question last time, Cole, so I can give you an easy one this time. Not intentionally, just, happened to happen.
It said structured data is information that is organized in an easily readable format. Data can be normally easily located and interpreted. Unstructured data is not organized in a readable format. So like a text file, a bunch of information is just on a file with no real order until it's literally formatted.
Right. So if we think about like a traditional Excel file, what would that be classified as? Structured data. Structured data. Unstructured data, it could actually be traditional data that doesn't have any organization. Like if you just have kind of a text file with no information, the organization to it, like just kind of information that's posted on there, or data or detail that's just posted on there at random. More recently, we talked about audio files and video files. Are those data files? Yes. Are those structured data files? Not really. Okay. It's very, very hard to disseminate what's going on in there. Now, we're not quite, we could argue that some data or some video and audio files do have structure to them. We're getting to the point that we can actually analyze those effectively. But for the most part, we consider those to be unstructured data because it's not something you would put into a traditional forensic data analysis tool and be able to look at. So how do these concepts relate to the idea of big data? Now, you have to understand what big data means, but we've talked about that before in other classes. So, Joe, what is big data, and how do these concepts relate?
We just said it is like large volumes of information with a variety of different forms being structured and unstructured. And they generate these massive amounts of both structured and unstructured data, which forensic data analytics can combine these different data types to get a more complete picture, allowing the analyst to detect the patterns and relationships with the data.
Okay, it's an important key of what Joe just said in there at the end right there. We go 15 years ago when I was working on forensic data analytics, then we could say, well, structured data is all that we can really access. That's all we can do data analytics upon. Is that going to be the goalpost? Is that going to be the goalpost anymore? Is that going to be what we want to look at anymore? If somebody says to you, forensic data analytics, we need to look at this audio file and look for patterns in it. Is that something that's going to be an expectation in this day and age? Yes. Okay. So even though it's unstructured data, there needs to be some sort of mechanism for being able to analyze this. And so even though we're not terribly familiar with those tools yet, it's going to be something that's going to be increasingly more common. And it's something that we could say the AI tools are going to be much more adept at analyzing than we would with our traditional data analysis tools. All right. So question number 7, Fraud Examiner's Manual identifies 3 testing techniques for forensic data analysis: ad hoc testing, repetitive testing, continuous testing. What are these things? So you didn't need to have access to the ASCE FEM, but you did need to do some analysis. So Jake, what did your group say ad hoc testing was?
We said ad hoc testing involves a one-use point-in-time analysis conducted for a specific project or exploration, like a fraud.
Yes, like a fraud investigation. That's kind of the good point. Good definition. All right. So how does this compare to repetitive testing? Jack, what is competitive test? Or sorry, what is repetitive testing?
Standardized tests that are run on a recurring schedule.
Okay, yeah. And so we would see this as being used on something that's going to be repeatable procedures on a routine task timeline. Usually when we think about this with forensics, this is going to be something that has consistently high fraud risk, and the fraud risk does not change over time. All right, and then continuous testing. Back to you, Alex. That was like Jeopardy. Yeah, back to you, Alex. What is continuous testing?
Said analytics that are applied on ongoing or real time, allowing organizations to detect unusual activity immediately rather than waiting for review.
Good. Will we say continuous testing is more of a preventive control or detective control? I would say it's more of a detective control. It's something where preventive controls actually cannot be as effective simply because they can't prevent problems from occurring. So we need to detect something that's going to take place so we can address it as it happens. All right, question number 8. It also contains a special section that says the challenges highlighted in digital forensics cloud computing. And I will say that cloud computing existed when I was doing digital forensics, but we didn't do analysis over the cloud. I got to imagine it's going to be a big challenge. So speculating on digital forensics over cloud assets might be more difficult than traditional forensic data analytics. Jenna, I've given you some pretty easy ones here. I think this is the hardest question of the entire day. So hopefully your group stepped up on this one.
Small improvement because of my focus access. Oops. Extra amount of data on the cloud. This can prove to be difficult to find the information that is needed for the investigation and increase the amount.
Good. So the access issues are definitely a problem when we talk about digital analysis of cloud data. Something also that kind of thing we can also speculate on is who has access to a cloud usually? Is it just usually just one individual or one entity? It's usually going to be a wide array of users, a wide array of users. So is it possible that you could be doing data analytics and that data analysis could, or the data, underlying data that you're analyzing could change as you're performing the analytics? Yeah. Yeah, so certainly problematic is how we actually capture that data and how we use the data. I think the traditional means of doing this currently is to capture all the data, download it, and keep it capture at a point in time, and then use that data as we would do a traditional forensics analysis. I don't think that's the most effective means, especially if we're talking about something that is constantly changing. It may not be a good mechanism for analysis, but it is something that we do need to be able to take into account. All right, so last question, and we got a little bit of time, and I'm sorry I scrolled down to names. I didn't mean to do that. So at this point in your academic careers, you should have a bit of experience with data analysis tools. Did anybody look at that statement and just laugh, or did everybody say, yeah, I feel like I'm pretty good about this? Oh, hopefully it's the latter. Okay, you feel pretty good. So I had you look at a case called the case of the disappearing printer ink, which apparently, from what I told, was a massive PDF, even though it was only 5 pages. But yeah, assume you've been hired to complete a forensic data analysis over the fraud at the Las Vegas Water Valley District. Provide an example of a query you'd run, assuming that you performed analysis using and then we talked about this. So easy one first, general analytics tool like Excel. All right, Cole, what would your group say on this one?
You can vouch purchase orders to see that they were actually requested, and then you could also use a pivot table to see who is requesting and purchasing the cartridges.
Yes, and so I'm glad that you said pivot table. Dr. Kane's birthday is today, so we actually had to keep her here in spirit in case, and she uses pivot tables for everything. So yeah, I had very similar results. I said pivot table, filter on locations and dates to note of any significant expenditures over time. So good answer on that one. All right, now we're moving on to the more specialized tools. And so, Joe, what will we do with a large data set analytics tool such as IDEA or Alteryx?
We said, we kind of went through like the tools to use, like we use like the select to find the vendor name, and you're able to count the invoices, kind of sum the total amounts to kind of determine if anybody's over purchasing using a different vendor or including fake or unusable vendors within like the query.
Good, good. I think there's a lot of different directions we could go with this particular tool. My answer was filter, identify high frequency and repeating transactions. That would be something that I would be very concerned about with respect to forensic data analytics, simply because a high frequency transaction has the tendency to be manipulated, as it was in the WorldCom case. That would be something that we want to be very aware of. So if it was something that's, especially if it's a repeating transaction over and over again. I was actually talking with some people yesterday in my class. They were asking if I'd ever caught a fraud, and actually one of the frauds that I had captured was a high frequency transaction for a very small dollar amount that occurred over and over again every month, multiple times. And so this is something that, from experience, I note is an important inflection point for this particular analysis. What about statistical analysis tools? What have we got on this one? Jake, what'd your group say on this one?
We said create a code function that analyzes all the purchasing information to compare statistics such as purchase ID or purchase by month, then compare these numbers to the operating needs of the company within the same time frame, and then review any periods or IDs with like very large outliers or periods where unnecessary purchases were made.
Good. So what do you all think about that with all your experience in R? It's been like a year since I've used R, so that was a much better explanation than I would have given. So let's be honest. Yeah. So yeah, I actually went in the direction of regression. So I set a regression on location, season, user amount, and any other relevant variables. To be honest, I didn't ever use any statistical analysis tools whenever we did analysis and forensic data analysis, but I do think that there's some value there, particularly if you're starting to see what you would expect to see for a pattern. If you can develop a linear regression that you think would be a good predictive model, and then you see very large outliers on that model, you could actually test those particular outliers along that. All right, and then the final one, data visualization tools such as Tableau and Power BI. So, Jack, what was your group's answer for this one?
In either tool, you could create a line graph to show the financial impact each year the fraud took place, and then you could also compare data from the Department of Justice to examine patterns of similar past crime and bar charts.
Good, good. I especially like the answer about a line graph because my answer related to the line graph. I said something called a Benford analysis. How many people have heard of Benford analysis? Wow, I get to tell you something new. Fantastic. All right. So this actually came from a long time ago. It was an engineer at General Electric who was using his logbook, and he noticed that when he was going through the logbook for his calculations, that the pages that had started with a digit of 1 were much more frequently used than others. And so he ended up testing this out, and it turns out that in naturally repeating data, that numbers that begin with a number, or I guess items that appear with the first numeral 1 occur far more frequently than those that occur with later digits. So naturally occurring data, the numeral starting with 1 is usually going to occur about somewhere between 25 to 30% of the time. Starting with 9 will occur only about 5 to 10% of the time, which is really, really weird and not what you expect. Now, how does this relate to forensics? If you're going to create a fraud and you're going to create amounts, are you just going to kind of arbitrarily toss out amounts that you think look good? And you're not going to pay attention to what they begin with. But the way that the number should, the distribution of numbers should look is it should be a naturally sloping down with the digits that begin with 1 and then go down to 9. This actually is true for secondary digits too. So 1, 1 is the most frequent, then 1, 2, 1, 3, and moves down in kind of a natural slope. So you could observe those in a line graph. So kind of an interesting little characteristic of numeric data. Now, keep in mind, this does not apply when we talk about selective data. So if you say that you got repetitive transactions at a certain amount, then you would probably see spikes of those amounts and it would not actually apply. But if you say, for example, you're an organization that's got an approval threshold at $50,000, what if we saw a spike at 49? Would you be suspicious of that as a forensic investigator? You'd say, okay, there's a spike at 49 in those digits, and we know the approval threshold is 50,000. It looks like people are making invoices for just under the approval threshold, try to get away with something they shouldn't. So some interesting analysis you can come up with just by looking at the detail within the data. All right, that kind of does it for today. So we will wrap up our investigation on Thursday. See you all then.
Okay.